starting off Unit 3. Unit 3 is going to be on systems of equations and inequalities. So today we are just going to be dealing with systems of equations, and we're going to be using just the first two methods of how to solve these. So what a system of equation is just how it sounds. A system of equation is just two equations okay, and we're trying to figure out if they meet. So two equations that may or may not meet. So may or may not have a solution, I guess we should say. May or may not have a solution. Okay, so like I said, there are three ways to solve these. The first way is just by graphing it. Second way is by what we call substitution. And then the third way is what we call elimination. And elimination we will not be talking about today, but we will be talking about next class. Okay, a lot of systems, you'll have multiple ways to solve, okay? Because obviously you could solve it through any of the three ways. So whatever way you end up preferring is probably the way you're going to want to solve it on the test, okay? When using systems of equations, there are also three different answers that you can get. You can get a one solution answer. Okay, and if we're graphing it, that's just going to look like a coordinate point. So a coordinate point is just x comma y. We can get a no solution when graphing. And what this is going to look like are parallel lines. So if parallel lines, are they ever going to meet at a point? No, because they're parallel, right? They have so much in common. It's a shame they'll never meet. But that's why it would be a no solution, because they never touch. And then the third way is called infinite solutions, which we have talked about these solution types in Unit 1 if they're coming back to us, right? When we solved equations, okay? Infinite solutions just means it's going to be the same line. So same slope, same intercept, all of it. Just overlapping lines or same lines. Okay, so let's go ahead and start. So steps on how do I solve these by graphing? Pretty simple. Graph line 1. Graph line 2. Do they meet? Or do they intersect? If so, what point? And then last but not least, we can check our answers just to make sure. Always good to plug things back in just to check. So the answer you get, if it's a one solution, it should work for both equations. So that xy point, if I plug it in, it should work. So I'll show you what we mean. So first off, my very first step is to do what? What does it say? Graph line 1. So this very first line is y equals negative x plus 1. So how would I graph that? What's the b value? 1. And my slope? Negative 1. So that means to go down 1 and right 1. Yep. Down 1, right 1, down 1, right 1. I can also go up 1 and left 1. Okay. So just for this first one, I'm going to go ahead and graph the full line. So all the way off my graph. It's probably a good habit to get into. Okay, so there's line 1. You with me so far? Okay, now what's my next step? Yep, graph line 2. So the b value is? And the slope? -2. So down 2 and over 1, or up 2 and left 1, which it looks like in order to intersect that other line, I'm gonna have to go up, aren't I? So now I've got line 2. Do these intersect? Yes, where? Yep, this point right here. So starting at the origin to get to that point, I would go left 3, so -3, go over to -3, go up 4. So it is this point right here. Okay, so that's my answer. The last thing I want to do is I just want to check these. And how am I going to check them? I can do it in my head, okay? Or I can just grab a calculator. And what I would do is I would plug in the 4 for y, I would plug in -3 for x in each of these statements, and just see if the left side equals the right side. So for this first one, does 4 equal -1 times -3 plus 1? Is that true? What's -1 times -3? 3 plus 1. Does 4 equal 3 plus 1? Yeah, so the first one's true, so I'm good there. And then what about the second one? So if I plug in 4 equals -2 times -3 minus 2, what's -2 times -3? 6 minus 2, does that equal 4? Yep, so I'm good. That's my answer. Always good just to get in the habit of checking them just to make sure you did it right, okay? No harm in checking them. What type of solution is this? One solution, no solution, infinite solution? Just one. Got one answer. Questions on that? No, it's not too bad. Looking at number 2, I just need to graph both those lines, right? Is the first the first line, is that in a form that I can graph? No, so I just need to, what? Yep, so add 3x on both sides. So this equation, I'm just going to cross it off and put y equals 3x plus 2, because that's what the new equation becomes. So now I have 2 equations that I can graph, right? What? Yeah, so we can flip that around, you're right. Yep. Okay, so b value on the first one is 2, up 3 over 1. Or down 3, left 1. Just like that. Sorry for the confusion. Okay, then the next one. My b value is -2. And the slope? Same as the first one, right? Up 3 over 1? Yup. So I'm going to graph that line. Okay. Do those intersect at a point? No. They do not. So what do we think this one is? No solution because they're parallel, right? So solution type is no solution. These are parallel lines. No solution because these are parallel lines. Okay? Questions on that? All right. Well, let's go ahead and move down. I want you to try this one. So get them both into a form that you can graph. graph them and then see, do they intersect or do they not? First one, what should I do? Yep, subtract the 3x over. So I'm just going to actually write this down here so I have more room. Subtract 3x over. I end up with 4y equals negative 3x plus 12, right? Can I graph that? No. Why not? Gotta divide the 4. Y equals?
Negative 3 over 4x plus 3.
Good. Raise your hand if you got that one. You knew how to get that equation into a graphable form. Woohoo! Nice. Okay, so how do I graph that one? Plot the 3. Down 3, right 4. Love it. Down 3, right 4. Or,
Up 3, left 4.
oh yeah. Okay. Just like that. Hopefully yours was a little straighter than that. Another great line drawer. Okay, what about the next one?
It's the same.
It's the same? So you're saying that the intercept is 3 and the slope is negative 3/4? So I'm plotting these same points? Whoa. Haha. What do you think this one is? Infinite solutions. Infinite. It's overlapping lines. These are the exact same line. Infinite solutions. You could also draw this little infinity sign. It's like a sideways 8. Too much work to draw infinity? Okay. 1 and 2 now. I want you to do these. You got it. Then we'll go over them. We'll learn our second method and we'll be done for today. First line, what is my b value? 5. So I'm going to put that on what axis? The y-axis. Good. Then Krista, what's my slope on that one? 1. So up 1 over 1. Up 1 over 1. Up 1 over 1. Or down 1. Left 1. So I've got this pretty line. Wow, that was not pretty. Another one. There we go. A little better. Okay. Next line. What is the slope on y equals negative 4x? Or, sorry, not the slope, the b value. B value. 0, because it's not written, right? This is the same thing as negative 4x plus 0. Okay. And then my slope, Luke, is negative 4. So down 4. Then what? Over 1. Good. Or up 4 and left 1, right? So now I have this line. Do those meet at a point?
Yeah.
Yes. What point?
Negative 1 over 5. Or negative 1 over 4.
Negative 1 comma 4, right? Because we gotta write it like that. What is the solution type? If I said, what is the solution type? Or how many solutions? 1. 1 solution. Okay, good deal. Moving right along. Number 2. We'll go ahead and just graph that first line. What's the b value? 4. And the slope? So I need to go up 1 and right 5, right? Or down 1 and left 5. Cool. Okay. second line, can I graph that the way it's written?
No.
No. I need to get y by itself, right? How would I do that?
Divide the 5.
Divide by 5. So this becomes y equals, so 1x divided by 5. 1 over 5. X, right? Plus 20 divided by 5. Whoa. Is that the same line?
Yep.
Yeah, it's magic. What is this one? Infinite solutions. Infinite solutions. It's the exact same line. Overlapping line. Okay. Then down here, we got just some little quick hints that we've kind of already talked about. Okay, but if you're just looking at the equations, if two systems, or just two sets of equations, have the same slope, but they have a different y-intercept, then what's the answer? They've got the same slope, but a different y-intercept. They're parallel, right? Which means that they are no solution. If they're parallel, they're no solution. So parallel means same slope, okay, but different y-intercept. But then, if I have the same slope and the same y-intercept, so meaning if I put them into y equals mx plus b, and they are the exact same, then what is the answer? Infinite solutions. So kind of like that last example that we just did. When we got those into y equals mx plus b, they were the same. They were the same. Okay, questions on that? Okay, do this one on your own. And do number 5. I thought we were done, but we're not done. Got 2 more. Okay, let's go ahead and look at these. So the first one, how did you get that into a graphable form? Negative 2x plus y equals 2. Yep, just add 2x, so you're going to end up with y equals 2x plus 2, right? Raise your hand if you got that one. Good. Plot your b value, which is 2, and then my slope is 2 over 1, right? Which is up 2 and right 1, or down 2, left 1. Whoa. Okay. It's kind of a bad line. Oh well. Next one. Can I graph that the way it is? X plus y equals negative 1? Nope. What do I need to do? Put it into y equals mx plus b by subtracting the x. So you ended up with y equals negative x minus 1, right? So my b value is minus 1, and my slope is down 1, right 1. Or up 1, left 1. Do these intersect? Yep, what point? Negative 1, 0. Good. So it's a 1 solution at negative 1, 0. Okay. Number 5. Actually, go back to number 4. We need a real quick check and make sure these work. We haven't been checking our answers. So on the first one, if I just take my calculator and I type in negative 2 parenthesis, what's x? In my coordinate, what's x? Negative 1 plus y, which is 0. Does that equal 2? Yes, it does. And then I gotta see, does x plus y equal -1? Does -1 plus 0 equal -1? For this one? Yep, it does. So we're good. Okay, last but not least, this one. It didn't even give us a graph. That was rude. I don't know what happened there. But I just want you to watch this one, okay? Since you don't have a graph, I'm not gonna make you try to draw one unless you did. Leave it there. But I'm just gonna graph this one here. But I'm gonna have you guys tell me what to do. So for this problem, number 5, what would be the first thing I need to do? Huh? Get y by itself. So I've got 2x minus y equals 2. How do I get y by itself? Good. So negative y equals negative 2x plus 2. Now what? Divide by -1. Good. So y equals
2x minus 2.
And to graph that, my b value is,
-2.
and my slope,
2/1.
yep, up 2/1. Or down 2 and left 1. So it'll look like this. Not like that. Like that. That's a little better. Okay, so there's my first line. What about x equals 4? Yeah, model that with your arm. What's that going to look like? Because it's a vux, right? It's a VUX. The V means vertical. Through the point on my x-axis where x is 4. Yikes.
That was a good one.
Oh my gosh.
Woo-woo.
Okay. Since you did that, what's the intersection on this? What's the intersection going to be?
Which one are we on?
The one I'm doing up here. Since you didn't have a graph. I'll zoom in. What's my intersection?
Over 4, 5.
Good. 4, 5. Okay. Now I'm going to go plug that back in down here, because that is my answer. So 2 times 4 is... What's 2 times 4? 8 minus 5 is 3. Well, let's go make sure we did that right. It should be going through 4, 6. You're right. I think my graph was just sloppy. Uh-oh. Yeah, it'd be nice if this tool would let me graph straight lines. But let's pretend I did that on purpose. It's good that I checked my answer, right? Because I just realized I did something wrong. This should be 4, 6. So now 4 times 2 is
8.
8 minus 6. I'm plugging these back into this. That's what I'm doing. It's 2. Okay, so the first one checks out. Now I just got to plug in x equals 4. I've got to plug in 4 for x. Does 4 equal 4? Yes. So this is my answer. Okay. Questions on that? Well, let's keep going then. Solving a system by substitution. So when using systems of equations, there are 3 different answers we can get. These are the same as before. 1 solution, no solutions, and infinite solutions. Write it out, infinite. In substitution, they're going to look a little bit different. 1 solution is still going to be an xy point, so that didn't change. No solution, though, is going to give me a false statement. So we've done conditional things before. Infinite solution is going to give me a true statement. Okay. Steps to solving by substitution. What you want to do is solve for y in one equation. Anybody remember doing this before? Because you have. Solve for y in one equation. Plug that in to other equation. Then you're going to solve that equation for x. And last but not least, plug the x back in to find what y is. Sounds like a lot, but once we get going on this, it's not going to be that hard. So solve for y, plug it in, solve for x, plug it back in. So no graphing on these ones. Okay, so what I want to do is look, is y solved for in either of these equations?
No.
No, it is not. So I just need to get y by itself. Which one do I want to pick? It doesn't even matter.
Top one.
The top one. Okay, so let's get y by itself on the top one. How do I do that? Add the 2x over. So y equals 2x minus 1. With me so far? Okay. So now that I have what y equals, I'm just going to go and plug that in to the y in the next equation. Okay? So what that's going to look like is just 4x plus 2 times my y equals 12. So plugging that in for y. Can I solve something that looks like that? Yes, by order of operations, right? What comes first? Parentheses. Do I have any parentheses? Yes, let's deal with those first. 2 times 2x. 2 times negative 1. What's 2 times negative 1? Negative 2. So now I've got 4x plus 4x minus 2 equals 12. Let's combine like terms. What's 4x plus 4x? 8x minus 2 equals 12.
So 8x equals 14.
Yep, so you add the 2 over, and 8x equals 14. Okay. Now what? Divide by 8. So x equals 14/8. Let's simplify that down though. 7 over 4. Let's do that. So x equals 7 over 4. Okay, so now I've got the first part of my coordinate point. I've got x. But I still need y. So now I can go and I can pick. I can plug that x into this equation, or even to this one. Because they're all the same. Or the first two are the same. So let's just go ahead and plug it into y equals 2 times x minus 1. So 2 times 7/4. Use a calculator. What's 2 times 7/4? Remember our ABC button.
7.
Not 7. I wish this one wouldn't have been a fraction. Yep, 7/2. So y equals 7/2 minus 1. What is 7/2 minus 1? Yep, 5/2. So that is my point. That's my answer. Okay. Last thing I can do is go and plug that back in and just make sure it works. Okay. We're not going to do that just to save time on this one. Number 2. Let's do this one together. So, which one do I want to solve for y? Top one, let's do it. So 3x plus 2y equals 10. How do I get y by itself? Subtract 3x. So 2y equals negative 3x plus 10. Now what? What do we think? Divide by 2. Divide by 2. So y equals negative 3/2 x plus 5. Good. Okay. Now we've got y by itself. We're going to go plug that into the next one. So 6x equals negative 4 times that y plus 20. Okay. What comes first here? Parentheses, negative 4 times negative 3/2. Type that into a calculator. What do you get? 6x. Negative 4 times 5. Negative 20. Now what? I'd like terms, so 20 and negative 20 is just going to be 0, so those are just going to cancel. Now I've got to get this 6x over. Well, when I do that, it ends up canceling on both sides. I'm just left with 0 equals 0. Is that a true statement? Does 0 equal 0? Yes. So this one is actually just going to be infinite. If I get a true statement, it's infinite. I don't have anything I can go and plug back in, because I don't have x equals anything. But I just have a true statement. So that tells me it's going to be the same line, which is infinite solutions. Okay? Questions on that? Number 3. Is y solved for in either one? Yeah, so I don't even have to do the first step. I've already got it. Done. Now I've got to go and plug that into what? What am I doing?
Plug it into y.
Plug it into y. In which equation?
The top one.
The top one. Good. So 3x plus 4 times negative 3/4 x plus 3, close parenthesis, equals 15. Now what? What comes first in solving? Parentheses, 4 times negative 3/4 x. 4 times 3. 12. Combine like terms on the left. What's 3x minus 3x? 3x minus 3x. What do we think? 0. So 12 equals 15. Does 12 equal 15? No. So what do we think this is? No solution. No solution. If you get a false statement, it's a no solution. Questions on infinite or no solutions? No? Okay. Go ahead and try these two examples on your own. You got it. You can work with somebody around you if you want to. Okay, first one. What'd you do? So we got y equals 2x and 7x minus y equals 15. Plugged in y to the second one? Okay, so 7x minus equals, okay, so this was just 7x minus 2x equals 15. What is 7x minus 2x? And what's x going to be? Yep, when you divide by 5, you get x equals 3. Now I got to go plug those back in. Which one should I plug it into? I'll plug that back in. Yep, that's the easiest one. So y equals 2 times 3. What's y equal? Huh? 2 times 3?
Wow.
Ooh, not 2 plus 3. 2 times 3 is 6. So this is just the coordinate point 3, 6. Raise your hand if you got that one. Almost. You're close. Okay, good. If you didn't, make sure you have it written down. Next one is y by itself in either of these. No, which one did you make, or which one did you solve for y? The first one? Okay. So we've got 6y plus 8x equals 28. Subtract the 8x over. So 6y equals negative 8x plus 28, right? Now what? Divide by 6. So y equals negative 4/3 x plus, what's 28 over 6? I don't think that's going to simplify. These are coming out to some weird fractions, aren't they? We'll just do 14/3. Okay? Next up, I've got to plug that in for y in the next equation. So 3 equals 2x minus a negative 4/3 x plus 14/3. Parentheses come first. So this is a negative 1. Becomes plus 4/3 x minus 14/3. A 2x here. Okay. We should not have picked one this hard. Let's just go ahead and skip this one. Okay? We'll get an easier one on the warm-up tomorrow. Okay, this one, if you want to keep going, this would become 6/3. Okay, we'd then add these up. It'd be 10/3 x. Add this over. Yeah, we got a lot of fractions going here. Let's not deal with that for now. We'll skip it. Okay? But if two systems of equation have the same slope but a different y-intercept, same thing. These lines are going to be parallel, which means, what does parallel mean? No solution. No solution. If they don't ever touch, it's a no solution. What about if they're the exact same? Same slope, same b value? Infinite. All right.